Welcome to Science Snippets, Fun Facts, and Trivia. Today, we bring you Quantum Mechanics Reveals the Terrifying Truth About Reality. Welcome to the strange world of quantum mechanics, where the familiar rules of reality no longer apply. Quantum mechanics governs the behavior of the smallest particles in the universe. But what exactly does this mean? Quantum mechanics emerged in the early 20th century, revealing a universe of uncertainty and probabilities. Unlike classical physics, which deals with objects we can see, quantum theory explains that subatomic particles exist in multiple places at once until we observe them. This introduced the strange idea that reality at the smallest level is unpredictable. One of the most famous concepts in quantum mechanics is wave-particle duality. Particles, such as light, can behave both as particles and waves. The double-slit experiment showed this duality when particles of light passing through two slits created a wave-like interference pattern. But when observed, the pattern disappeared, and the particles acted like solid objects again. This revealed that observation changes reality at the quantum level. The double-slit experiment and Schrödinger's cat illustrate how quantum mechanics challenges our understanding of reality. The observer effect, revealed in the double-slit experiment, shows that simply observing a quantum particle alters its behavior. Schrödinger's cat highlights the concept of superposition, where particles exist in multiple states at once. In this thought experiment, a cat is both alive and dead until observed. Quantum mechanics doesn't just describe a world that's different from what we see. It forces us to rethink the very nature of reality. Some of its implications are not only strange, they're downright terrifying. One of the most unsettling ideas in quantum mechanics is superposition. This concept suggests that particles can exist in multiple states or places simultaneously until we observe them. In other words, a particle isn't here or there, it's both, existing in a state of potential. This means that reality, at the smallest level, is not definite until it's observed, challenging our understanding of a fixed universe. Then, there's quantum entanglement, where two particles become connected in such a way that the state of one instantly affects the state of the other, no matter how far apart they are, even across galaxies. This phenomenon seems to defy the laws of physics, specifically the rule that nothing can travel faster than light. Albert Einstein famously called this spooky action at a distance. It's as if the universe allows instantaneous communication between particles, hinting at a deeper, hidden layer of reality that we don't fully understand. Perhaps the most eerie aspect of quantum mechanics is the observer effect. It suggests that reality depends on whether it's being observed. In quantum experiments, particles behave one way when they're unobserved, but change behavior once they're measured. This raises an unsettling question. Does reality even exist when we're not looking? It seems that at the quantum level, the universe only settles into a state of reality when we interact with it. Quantum mechanics doesn't just stop at bizarre particle behavior. It opens the door to the possibility of multiple realities. The idea that there could be an infinite number of parallel universes is one of the most mind-bending implications of quantum theory. One of the more radical interpretations of quantum mechanics is the many-worlds interpretation. This theory suggests that every time a quantum event occurs, the universe splits into multiple versions. Each version represents a different outcome of the event. So, if you were to make a choice, say, picking between two doors, one version of you opens door A while another version of you opens door B in a parallel universe. In this view, every possible outcome happens somewhere, creating a vast multiverse of infinite possibilities. Another strange idea is the concept of quantum foam. At the smallest scales, space and time themselves become uncertain, bubbling with tiny fluctuations in energy. This bubbling activity suggests that space-time is not smooth, but chaotic at the quantum level. Some scientists believe that these fluctuations could create tiny, temporary universes that blink in and out of existence in a fraction of a second. While most vanish instantly, it raises the question: could one of these quantum bubbles expand into a full universe like ours? If these theories are true, it's possible that our universe is just one in an endless sea of alternate realities. Each reality could have its own set of physical laws, or even entirely different versions of you, me, and everyone we know. While this might sound like science fiction, some physicists believe the multiverse is a real possibility, one that would forever change how we think about our place in the cosmos. Quantum mechanics doesn't just challenge our understanding of the physical world. It also raises deep questions about human free will. If reality is governed by probabilities, how much control do we really have over our own choices? At the heart of quantum mechanics lies probability. In classical physics, we can predict events with certainty. But in quantum mechanics, we can only predict the likelihood of a particle being in a certain place or state. This randomness at the quantum level suggests that the universe isn't entirely deterministic. Things don't happen because they must, they happen based on probabilities. If the very fabric of reality is uncertain, it's hard to say how much control we truly have over events in our lives. This idea of quantum uncertainty spills over into the question of free will. If our brains, like all matter, are governed by quantum particles, does that mean our thoughts and decisions are also subject to the same randomness? Some interpretations of quantum mechanics suggest that, while we might think we're making choices, those decisions could simply be the result of random quantum events in our brain, beyond our control. In other words, the freedom we feel might just be an illusion, created by the unpredictability of quantum processes. The philosophical implications of quantum mechanics are profound. If quantum events shape the universe, and even our brains, does this leave room for genuine free will? Some argue that quantum randomness could be the key to unlocking free will, offering an alternative to the strict determinism of classical physics. Others believe that this randomness doesn't equate to freedom, but rather to unpredictability, meaning our actions are still out of our control, just not in a predictable way. Either way, quantum mechanics forces us to reconsider how much agency we truly have over our decisions. Quantum mechanics has turned our understanding of the universe upside down. It challenges the traditional view of a predictable, clockwork universe, and replaces it with one governed by uncertainty, probability, and strange new possibilities. For centuries, classical physics ruled our understanding of the universe. Newton's laws of motion, for example, painted a picture of a universe where everything behaved in predictable ways. But quantum mechanics showed us that this only applies to the macroscopic world. At the atomic and subatomic level, predictability fades and reality becomes a web of probabilities. This shift from certainty to uncertainty marks one of the biggest paradigm shifts in the history of science. Quantum mechanics isn't just a theoretical curiosity. It has real-world applications. From semiconductors in smartphones to MRI machines in hospitals, many modern technologies rely on quantum principles. The most exciting development is quantum computing. Unlike classical computers, which process information in binary bits, zeros and ones, quantum computers use qubits, which can exist in multiple states at once. This allows quantum computers to solve complex problems much faster than traditional computers, potentially revolutionizing fields like cryptography, medicine, and artificial intelligence. As we continue to explore the mysteries of quantum mechanics, the potential for new technologies and discoveries is immense. Quantum teleportation, quantum encryption, and even advances in space exploration could emerge from our growing understanding of this strange field. The future of science may very well depend on our ability to harness the power of quantum mechanics, unlocking new possibilities and revealing deeper truths about the universe that we can only begin to imagine today. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.